Question 7 is on vectors, and it's a question pretty much in two parts. So the two vectors we're given are u equals -3, I plus j plus k, and v equals mj plus nk, where m and n are elements of the real numbers. We are told that given that v is a unit vector and perpendicular to u, find the possible values of m and n. So the first stage of this is fairly straightforward. We know that if two vectors are perpendicular, then their dot product is equal to 0. So we can calculate the dot product here. So for u, there's -3i, and there's no I in v, so it's going to be -3 times 0, plus 1j here and mj here, so 1 times m, plus 1k here and nk here, so that is going to be 1 times n. We know that that equals 0, so we can simplify that down to m plus n equals 0. So we end up here with m equals -n, which is problematic because there are an infinite amount of solutions to that. However, the key thing to recognize here is that v is a unit vector. So that actually enables us to form another equation, because if v is a unit vector, we know that the magnitude of v must be equal to 1, because it's a unit vector. So that's the definition of a unit vector, is a vector of length 1. So the magnitude of v must equal to 1. You can find the magnitude by finding m squared plus n squared, adding that together, and that gives us 1. So what we can do now is substitute in, for instance, if m equals -n, we can substitute that in. So -n squared plus n squared equals 1, which gives us 2n squared equals to 1. So therefore n squared equals 1/2, and n is going to equal 1 over root 2, plus or minus 1 over root 2, sorry. Similarly, therefore, m will also equal plus or minus 1 over root 2, and those are the possible values of m and n.